Okay, in this unit 3, we're going to learn about this mobile propagation, small scale fading, and multipart. So, in the last class, we already discussed regarding this multipart. From the tower, it sent out a lot of channel in a multiple path, and the mobile station receive these different types of signal from the tower. Let's see here one more example. Okay, this multiple here based on this multiple part. Okay, multiple part combining that mobile receive a multiple signals, and also the object reflect those signal also in the multipart radio signal. So let's go into this small scale multipart propagation. Small scale fading or simple simplified fading is used to describe the rapid fluctuation of the amplitude phase or multipart delay of a radio signal over a short period of time or travel distance, so that large scale path loss effect may be ignored. So if the rapid fluctuation, this small scale fading or fading implies that the rapid fluctuations of amplitude and phases. Amplitude means that the signals in analog communications, it changes in the amplitude side, and also it changes in the phase also. Amplitude and phase means what? Okay, amplitude and phase in the signal is, the amplitude is this side. I hope that it already understand this one. This is the amplitude. Okay, and phase is what? Phase is each and every cycle of this cycle of the analog signal. Each and every cycle of this signals, we have a sine wave. We have a sine wave. This calculated using this coordinate geometry. Okay, coordinate geometry in these analog signals. Let's log. See. Okay, where is the it's not coming here properly, the circle and this analog comparison. Okay, anyway, this is the example of the sine wave. Each and every completed circle create a complete frequency. This is the example of the circle, and the time is there. This time create the complete circle, and it's complete the one cycle. Then is called this 1 hertz in the frequency. Then this is made by the amplitude and the frequency. Uh, did you learn before this amplitude, frequency, phase, all these things before? Before, am I in loser to em?
riêng lem lo cho mà sẽ analog signal le digital signal ka chu misma lo mi kan tlem mi ti pui
Amplitude tite, phase tite, frequency tite.
oh kha chu tin rol ta tho
In theater.
yes sir
So you don't lenga lotro. Okay, if it's there, then it's okay. So here, fluctuation of amplitude, phase, and multiple delay of the radio signal over a short period of a time of travel distance, so that large part loss effect may be ignored. So there's lots of loss that a short period of time travel distance. Okay, so a short period of travel time distance means if the system, mobile system, or the mobile user moving too fast. Okay, then there are some large scale part loss effect may be ignored. We have to ignore in this small scale part propagations. And also fading is caused by the interference between two or more versions of transmitted signals which arrive at the signal at slightly different time. So this means that fading is caused by what? Interference between two or more versions of transmitted signals. So from the tower, it's transmitted this multiple part. So it's having the interference. Okay, this fading is caused by the interference between two or more versions. Two or more versions means one part arrive, another part arrive, another part arrive. This is it's reflected by different part of object like buildings or maybe a mountain or maybe a blocks of wooden or maybe a blocks of copper or anything can reflect it, all those things. Then this version of transmitted signal arrive at the receiver at the slight different times. So different times is received. This one, this is called fadings. It will fade it each others. Then it's having this interference. Okay, these waves called multipart waves. These different types of multiple signals arriving to the system. Okay, arriving to the systems in a different forms, different versions, different signals. So from the origins, it's come out at the same time. But if it's moving too fast from my point, from the current point to maybe 1 meter point, it's take only 2 seconds. The moving device taking only maybe 2 3 seconds. At the same time, from the current positions to the new positions. Okay, let uh, right here. Here, this is the current positions. Here the object is moving to the new positions. Okay, from these positions, from these positions to these positions, the multipart signal coming from here and the same multipart signal coming from here. Okay, so these two objects moving Sorry, not two object. This single object means the device. Okay, maybe a mobile phone or any network receiving equipment is moving towards this point, but it's very fast. Okay, it a very fast moving object. So at some point, at some point, it received the same signal. Let me share you my whiteboard. Try to share. Here is very difficult to write. Can you see my whiteboard right now? In low mutem whiteboard ka.
Yes, sir.
Hmm. Ilahi, let me explain it this one. What is a multi-part wave and these things using this whiteboard. Object mobile device. This is the example of the mobile device. It's moving towards from this point. Okay, from this point towards this, and here we have a mobile tower here. From the mobile towers, it transmit different type of signals using a multi-part. Using the multi-part, it transmit the different types of signal. Okay, this is the tower. Then it transmit the multi-part signal this way. Okay, and here multi-part signal, and here one building is there, and also here one building, another building, here one building. Okay, then this object reflected back the signal to this, and also is receiving this one. Here is received this, then this object coming here and reflect it back, it receive. Okay, so this mobile moving towards this in a very fast motion. Then here it received the same signals, and it received the same signal with the different versions. Okay, different versions. That's why we called here two or more versions of transmitted signals which arrive at the receiver at slightly different times. Okay, slightly different times. These waves called multi-part wave combined of the receiver antenna to give the resultant signals, which can vary widely in amplitude and phase. Okay, it's vary in the amplitude and the phase. I already explained this. We have amplitude and the phase. Phase means we have a changes in the degree of this sine wave. Maybe in the changes in the 90 degree, or maybe changes we have in the 230 sorry 180 degree, or maybe 270, or maybe 360, or maybe in between this 45 degree there may be changes. Okay, Okay, these are the things multipart. There are some changes in the amplitude and phase. Depending